The universe constantly reminds us how little we know. We drift on our blue world, a tiny island in a vast cosmic ocean. Sometimes a message arrives, not in words, but in rock, ice, and dust. These are visitors from other star systems carrying secrets from places we can only imagine. Today, August 22nd, 2025, we meet a new messenger, 3I Atlas. The I stands for Interstellar. This object is not from our solar system. Its discovery was a quiet triumph found by vigilant telescopes scanning the night. 3I Atlas is a tangible connection to the greater cosmos, proof that our solar system is not alone. But this visitor is deeply strange, forcing us to rethink what we know about planetary systems. The universe is speaking, and we're just learning to listen. The story of 3I Atlas is a story of discovery, mystery, and our relentless quest for knowledge. Before the era of advanced sky surveys like Atlas, there was Oumuamua, a true messenger from the distant reaches of space, carrying secrets from beyond our solar system. Discovered in October 2017, Oumuamua became the first confirmed interstellar object ever detected passing through our solar neighborhood, a historic moment in astronomy. Its sudden arrival stunned astronomers worldwide. For decades, scientists had theorized that objects from other star systems might occasionally visit us, but until Oumuamua, none had ever been seen. The discovery electrified the scientific community and captured the public's imagination. Oumuamua was unlike anything we'd ever observed. It was small, oddly elongated, shaped more like a cigar or pancake than any known asteroid or comet, and it tumbled end over end as it traveled, reflecting only a faint glimmer of sunlight. We had only a brief window, just a few weeks, to study it before it sped away, vanishing into the darkness between the stars, never to return. Its most baffling trait was its acceleration as it left the sun. Instead of slowing down as gravity would predict, Oumuamua sped up as if propelled by some invisible force that defied our understanding of physics. Yet there was no visible cometary tail, no outgassing, no dust, just a silent, mysterious push that left scientists scratching their heads. Was it made of exotic ices that evaporated invisibly? Was it a new class of object, unlike any asteroid or comet we'd catalogued before? Or, as some speculated in hushed tones, could it even be an alien artifact, an interstellar probe sent by another civilization? Oumuamua slipped away, leaving us with far more questions than answers. A fleeting ghost from the galaxy, its true nature still shrouded in mystery. But its visit proved that interstellar objects are not just theoretical, they are real, and they can be stranger than anything we imagined. Oumuamua's brief appearance set the stage for future discoveries, reminding us that the universe is full of surprises and rarely conforms to our expectations. It was the first interstellar visitor we recognized, but deep down we knew it would not be the last. The cosmos is vast, and more messengers are surely on their way. Now, with new technology and ever-watchful eyes on the sky, we're ready for the next encounter, eager to unlock more secrets from the stars. As the heated debates and wild speculations about Oumuamua slowly faded into the background, the universe, in its infinite unpredictability, decided to surprise us once again, reminding us how little we truly know about the vastness beyond our solar system. Just when astronomers thought they had seen it all, a new cosmic visitor made its entrance, catching everyone off guard. In the early months of 2025, the Atlas telescopes, originally built to detect asteroids that could threaten Earth, detected something far more mysterious and intriguing than anyone had anticipated. What they found was a faint, elusive object racing across the sky on a hyperbolic trajectory, moving so quickly that it was clear it could never be captured by the sun's gravity. This enigmatic traveler appeared to come from the direction of the constellation Lyra, marking it as a genuine interstellar visitor, one that had journeyed for untold eons through the emptiness between the stars. Astronomers quickly confirmed this was only the third interstellar object ever detected, soon to be named 3I/Atlas, following in the footsteps of Oumuamua and Borisov. Unlike Oumuamua, which was discovered after it had already passed its closest approach, this time we had the advantage of early detection, giving us precious time to prepare and study it in unprecedented detail. The astronomical community sprang into action, coordinating a global network of observatories and scientists. Telescopes around the world swiveled in unison, all focused on this faint, fast-moving traveler from another star. For the first time, we could watch an interstellar object as it approached the Sun, observing its behavior and any changes in real time, hoping to catch clues about its composition and origins. And as it began its long journey out of the solar system, we could continue to track it, gathering data as it faded into the darkness once more. This was our golden opportunity to answer the lingering questions that Oumuamua had left behind. Questions about the nature of these mysterious visitors from the stars. The anticipation among scientists was electric. What secrets would this new object reveal? What was it made of? What was its true shape? Could it finally help us understand the diversity of objects that drift between the stars? Would it behave like a familiar comet, shedding gas and dust as it neared the Sun? Would it resemble an asteroid, rocky and inert? Or would it defy all expectations and behave like something entirely new? For the first time, we had a real second chance, a rare opportunity to study a piece of another world, a messenger from the distant reaches of our galaxy. This time, we were ready. The world's best instruments and brightest minds were prepared, determined not to let this cosmic visitor slip away unnoticed. The race to unlock its secrets had begun, and with it, the hope that we might finally glimpse the wonders that lie beyond our own solar system. As 3i Atlas drew closer, telescopes revealed its secrets. The James Webb Space Telescope captured images of a bizarre, fragmented object, not a single body, but a loose cluster of large chunks. These fragments flew in tight formation, surrounded by a faint cloud of dust and gas. This was unexpected. Interstellar space should destroy fragile objects. Did it break apart near the Sun, or has it traveled fragmented for eons? The haze around it was thinner than any comet's, as if it tried to be a comet but lacked the right ingredients. The detected gas had unusual chemistry, hinting at a different origin. 3i Atlas was a cosmic contradiction, breaking apart like a weak comet, but with almost no tail. It didn't fit any known category, asteroid or comet. The universe had thrown us another curveball. The mystery was only getting deeper. We were witnessing something entirely new. Placing them side by side, 3i Atlas and Oumuamua appear as different as they are similar. Both are rare guests from the vastness beyond our solar system, yet each brings its own set of puzzles and surprises, challenging our understanding of what drifts between the stars. Both are interstellar travelers, small, dark, and weathered by countless years exposed to the harshness of space. Their surfaces tell silent stories of cosmic radiation, ancient collisions, and journeys that began in distant, unknown star systems. Yet, both objects defy simple classification. They are neither just asteroids nor comets, but something in between. Enigmatic hybrids that don't fit neatly into the categories astronomers have used for decades. Oumuamua's mystery was its bizarre, elongated shape, unlike anything seen before, and its unexplained acceleration as it sped away from the Sun. Some scientists speculated this could be due to invisible hydrogen ice evaporating, while others wondered if it hinted at even stranger origins. In contrast, 3i Atlas shows no such acceleration. Its strangeness lies in its fragmented structure, as if it broke apart before or during its journey, leaving a ghostly tail of dust and debris trailing behind it. Where Oumuamua was a single solid object, like a cosmic shard, 3i Atlas is a loose cluster of fragments, a fragile collection barely held together as it races through space. This contrast suggests very different origins. Oumuamua may have been a solid rock or a chunk of exotic ice, ejected whole from its home system. 3i Atlas, on the other hand, could be the shattered remnant of a larger body torn apart by gravitational forces or violent events in its own star system's outer reaches. The key takeaway is clear. Interstellar objects are wildly diverse, each one a unique messenger from the galaxy, carrying clues about the places and processes that shape them. Imagine if the first two people you met from another country were complete opposites, a basketball player and a poet. You'd instantly realize there's a huge range of possibilities out there, far beyond any single stereotype. Likewise, these two cosmic visitors show us that the galaxy produces a menagerie of oddities, each new arrival expanding our sense of what's possible in the universe. There's no such thing as a standard interstellar wanderer. Each one is a singular story, a cosmic outlier with its own history and secrets. And as our telescopes grow sharper and our searches more ambitious, we've only just begun to meet these mysterious travelers. The next visitor could be even stranger, and each one brings us closer to understanding the true diversity of our galaxy. Why is 3I Atlas even weirder than Oumuamua? Oumuamua's mystery could be explained barely by exotic ices. 3I Atlas, however, is a bundle of contradictions. It's fragile and fragmented, yet barely active, like a snowball that crumbles without melting. No comet from our solar system behaves this way. How did it survive millions of years as a loose cluster, buffeted by galactic forces? Did it break apart recently, or is something holding it together? It defies our models of interstellar objects. Oumuamua gave us one big question. 3I Atlas gives us a tangled knot of mysteries. Why is it in pieces? Why so little gas? Why do the fragments stick together? Every answer raises more questions. It's a puzzle where the pieces don't fit, outweirding Oumuamua by being fundamentally stranger. Faced with such a bizarre object, scientists are forced to get creative. One idea that 3I Atlas is a fluffy primordial body, like a cosmic dust bunny, lightweight, porous and fragile. Another theory, it's made of exotic ices, like solid carbon monoxide or nitrogen, which vaporize far from the sun, but this doesn't explain the weak outgassing. Maybe a crust traps the volatiles inside. Some even speculate about artificial origins, alien technology or debris. There's no evidence for that, but the strangeness invites speculation. Most agree it's a natural object, but one unlike anything we've seen. It could be a primordial planetesimal, a building block of a planet ejected before it could grow. Its properties offer clues about its home system's chemistry and physics. The truth is likely stranger than we can imagine. Why dedicate so much effort to a single crumbling object? 3I Atlas is a cosmic Rosetta Stone, a key to deciphering the language of other solar systems. We can't travel to other stars, but these objects bring pieces of them to us. By studying its light and gas, we learn about its chemical makeup. Early results show it's different from our comets. This helps us understand the diversity of planetary systems and where life might arise. Its fragility and behavior reveal new insights into planet formation. Studying its weathered surface tells us about the interstellar medium, the cosmic ocean it sailed. Each mark is a clue to the storms and currents between the stars. 3I Atlas is a messenger and a record of the galaxy's history. The discoveries of Oumuamua and 3I Atlas are just the beginning. We now know interstellar objects are real and can be found. The upcoming Vera C. Rubin Observatory will scan the sky with unprecedented speed, likely finding dozens each year. Imagine a future catalogue of hundreds of these visitors, each revealing new secrets. We'll see the full diversity of objects other solar systems produce. This will transform our understanding of the galaxy's ecology. If we find them early, we could even send probes to intercept and study them up close. Such missions are being designed now. A voyage to touch an object from another star. As we puzzle over 3I Atlas, we look forward with excitement. The universe is filled with wonders, and the search continues. Our journey has just begun.